If you are looking for a solution to WASSCE 2025 Phases Paper 2, then you find yourself at the rightful place. In this video, I'll be solving the questions for WASSCE 2025 Phases Paper 2. Now, let's dive into business. Question number 1. A ball thrown vertically upward attempts a velocity v after experiencing a retarding force F equal to lambda times v. Determine the dimension of lambda. Now, before we solve this question, it is pertinent for us to know what dimension or fundamental quantity actually is. When we talk about dimension or fundamental quantity, we simply mean the power to which the fundamental unit must be raised to obtain a unit of that physical quantity. Dimension of any fundamental quantity is always enclosed in or curly bracket. For example, if we say the dimension of F, it can be written as curly bracket of F, which represents the dimension of the force F. Now, in this question given to us, we were asked to determine the dimension of lambda. So the first thing here is for us to make lambda a subject in this equation given to us. So the equation is F is equal to, we have F is equal to lambda times V. So when we make lambda the subject here, we divide both sides by V, we will have lambda to be equal to F or V. But already as the dimension of lambda equal to the dimension of F or divided by the dimension of V. All we need to do now is to replace the dimension of the force F and divide it by the dimension of velocity V. From our little knowledge we have in physics, we know the dimension of force, the dimension of force F is given as capital M times L T to the minus 2. Now, in mechanics, the dimension of any physical quantity is always expressed in terms of M, L, T. So note this. So the dimension of velocity, which is V, we say dimension of V can be written as M to the 0, we have L T to the minus 1. Now, we write M to the 0 power here because in mechanics, we always express the dimension of any fundamental or physical quantity in terms of mass, length, and time. For the sake of simplicity, we express the dimension of any physical quantity in mechanics in terms of the dimension of mass times the dimension of length, whatever the dimension of time. So note this. So what we need to do here now is we just need to replace the dimension of F divided by the dimension of V to obtain the dimension of lambda. So this can be written as, we have the dimension of F now is MLT to the minus 2. So we have a dimension, put in curly brackets. Don't forget the dimension of, we have M L T to the minus 2, curly bracket close it, all divided by, we have the dimension of V, which is M to the 0 times L T to the minus 1. Now, dividing this by this, we can see that, look here, M and M, the two bases are the same. We can take one base and the exponent will come up. It changes to, we're having what? We're having 1 here. So, or 1 minus 0 will have 1. L and L, we have the exponent of 1 and exponent of 1. They won't going out. So that will make life easier for us. We have M. We having 1 here, so there's 0. So having 1 minus 0, it is same as 1. We level 1. L and L will take one of the bases. So we have L. Here we're having exponent of 1 here, and we're having the exponent of 1 here. So having 1 minus 1 here for L. So we have 1 minus 1. And here we're having T and T the same. We take 1 T. So we have T. And here we have the exponent of negative 2. Negative 2. And this is negative 1. It comes up and change to positive 1. So negative 2 plus 1. So simplifying this, we'll have the dimension of M to the 1, now we L to the 0. And T to the minus 1. All right, so this is the expected answer for question number 1, WASSCE 2025. Now, let's move to question number 2 and see. Question number 2, a particle is projected from the ground with a speed of 40 meters times second inverse at an angle of 60 degrees with the horizontal. Calculate the distance made with. Now, the question here asking you to calculate or to determine the distance that is made with. Made with means halfway. So the first thing we want to know is that when we talk about the horizontal distance, the same as the range. So here, considering this to be the path traveled by the projector, they also the projector travel like this in the parabolic curve or path. The distance from the point of projection to where the projector landed is all called a range. And the range here is represented by capital arrow. Now, but the question asks you to find the distance made with. So it means that half the horizontal distance gave all the distance made with. So you can write the distance or the horizontal distance made with is just equal to the range divided by 2. So this is the concept behind these questions. So now let's solve the question together. We know that the range of the projectile is equal to the square of the initial velocity u times sin of 2 theta all divided by epsilon to the capital G. Since we are calculating the distance made way, we divide the range by 2. So dividing this by 2, we'll have our new formula to be the range made way. The range made way is equal to u squared times sin of 2 theta sin of 2 theta all divided by, reciprocating this, we'll get 2 times g give us 2g. So we have all divided by 2g. Now, let's substitute our favorite values and see. So here we have, in the question, we have the initial velocity to be equal to 40 meters times second inverse, and we have the angle of projection to be 60 degrees. So replacing the values, we have arrow, the range made way, to be equal to u here is 40 degrees, 40 meters times second inverse. Sorry, so we have 40 u squared, so square it, all square times sin of 2 times theta. Theta given to us in the question is 60 degrees. All divided by 2 times g is constant. 7 cavity is 10 meter times second square inverse. So we get rid of 10. So now we have the range made with 40 times 40. It gives us 1,600. So at 1,600, multiply by 2 times 60 give us 120. Sin of 120 degree gave us 0.866. So at 0.866. All divided by 2 times 10, 20. So our final answer here, placing this in the calculator, multiplying 1,600 by 0.866 and dividing our result by 20, it gives our final answer to be the range made way to be equal to 69.28 meters. 69 when 2, 8 meter. Question number 3. A satellite orbits at 2.5 times 10 to the 4th power kilometer above the Earth, taking 15.5 hours to complete its orbit. At what speed will that orbit take place? Take the radius of the Earth to be 6.4 times 10 to the 3rd power kilometer. The question asks us to calculate the orbit speed. Now, the speed of the orbit is given at V is equal to the total distance covered by the satellite to complete one orbit, which is given to us at the circumference of the circle, the circumference, all divided by the time or period taken to complete its orbit, T. We do know that the circumference of a circle, C, is equal to 2 pi r. So we place C by 2 pi times r. Now, r in this particular equation here represents the total orbit distance or the total orbit radius. So here we place we have V to be equal to 2 pi r all divided by the period taken by the satellite to complete its orbit, T. But we need to find the value of r here. R here represents the total orbital radius. So the total orbital radius is given as a sum of the radius of the Earth given to us here plus the altitude of the satellite. So we can say that R is equal to the sum of the Earth radius plus the height or the altitude of the satellite H. So now we have the radius of the Earth given to us as 6.4 times 10 to the 3rd power kilometer. And the altitude of the satellite given to us here is 2.5 times 10 to the 4 power. For the simplicity of the video here, we would write these values given to us in the standard form, we'll write it in the expanded form and solve. If you want to leave it, you can leave it there and solve, you still come to the same answer. So we have R to be equal to log here. The rate of the F is 6.4 times 10 to the 3rd power. Writing this in expanded form will have 6,400 plus the altitude of the F given, the altitude of the satellite given to us is 2.5 times 10 to the 4th power. Putting it in the expanded form will have 25,000. So we'll add 25,000 plus 6,400. We will have the value of 3,140,000 kilometer. So the sum of the F radar plus the altitude of the satellite given to us is 31,400 kilometers. That's the value of R. We can now determine the speed at which the satellite will orbit. So we have V to be equal to 2, the value of pi is 3.14, but since the value not given to us, I take 3.142. 3.142 times our here now is 31,400. So we have 3, 1. Then we erase this to get white space. All right. So then we place our value for arrow to be 3, 314 0 0. All divided by the period given to us, 15.5 hours. So we have 15.5. Now, placing this in the calculator, multiplying 2 times 3.142 multiplied by 31,400, we will have V to be equal to, placing the calculator, you have 1,973,117.6, all divided by the period 15.5. 15.5. Now, solving this, we'll have V to be equal to 1, 2, 7, 30 kilometer per hour. Per hour. Kilometer per hour, sorry. So we express our answer in kilometer per hour. But if we want to express this value in meters per second, we need to do our conversion from kilometer per hour to meter per second. So the easier way to do the conversion, multiply this value by 1,000 kilometer and divide your final answer by 3,600 seconds. So doing this, we'll have our final answer of V to be equal to 3,5. We have 3,536 meter per second, or say second inverse. So this is our final answer. Let's move to question number 4. Question number 4. A certain simple pendulum has a period of 1.75 seconds. Determine its period when the length is quadruple. Now, the word quadruple means 4 times. So in the question, we are told that the simple pendulum has a period of 1.75 seconds. So this value given to us represents period 1 or T1. So we can say it T1 T1 equal to 1.75 seconds. Determine its period. That is value for T2. We are already given T1, so T2 is unknown. We were asked to determine T2. So T2 or period 2 is equal to question mark. When the length is also unknown. So we were not given the original length of the pendulum. So we can say the original length L1 is just equal to L. Because when the length is quadruple, so L1 will be equal to L. And the new length, L2 is quadruple. Quadruple means 4 times. So L2, which is the new length, is equal to 4 times the original length. So say 4 times the original length there is L. Now, we know that the period of the pendulum, T, is equal to 2 times pi times the root of the length of the pendulum, all divided by 70 converted G. So this is the formula for calculating the period of the pendulum. Now, from this equation, we can see that the period is directly proportional to the length L. So we can rewrite this as, since we're having 2 periods and 2 lengths, we can rewrite it as T1 all divided by T2 will be equal to the root of L1 all divided by the root of L2. Squaring both sides to eliminate the root, we'll have T1 squared all divided by T2 squared to be equal to L1 all divided by L2. Let us substitute our value. So replacing the value for T1 given to us, in the question we have 1.75. close all square. Divided by, we don't have T2, so T2 remains. So have T2 square equal to L1 equal to L. So we have replaced L by the initial length or the original length, and L2 equal to 4 times L1, or just a 4 times L. So we say 4 times L. We can see that L will cancel L. So having 1 over 4. During our cross multiplication, we have T2 square equal 4 times 1.75 second closing. Now, we want to find T2, not T2 square. So we need to ostracize or eliminate the square by taking the square root on both sides of the equation. So taking the square root on both sides, and taking the square root on both sides of the equation, T2 square, moving from the root, we have T2 to be equal to, the root of 4 is 2. And remember that this 1.75 is also square. It's square here. So remember this is square. So when we take the root of 1.75 square, the square will drop, and we get left with 1.75. So we have times 1.75. So multiplying 2 times 1.75, our final answer will be T2 to be equal to 3.50 second. Now, we maintain 2 decimal places because the question was given to us in 2 dp. So here, the period or the first period was given to us as 2 dp, so we need to maintain our 2 decimal places. Thank you. Let's move to our next question. Question 5, state 3 uses of optical fibers in manufacturing industry. Now, an optical fiber is a thin and flexible glass rod or plastic rod. In fact, it is so thin and flexible that it can easily pass through the hole of a needle. Optical fiber, it comprises of 2 major parts. It has the core, which is a central part, and the core is surrounded by the outer layer called the cladding. Apart from optical fibers being used in manufacturing industries, it has other basic uses in the medical field, and also it has uses in telecommunications. Like for the medical field, the dentists usually use optical fibers to view down the throat of the patient. And we have our medical instrument called the endoscope. The endoscope uses optical fibers to view internal organs of the human body. Now, let us see some basic uses of optical fibers in telecommunications. like 90,000 of or telephone call or communication that will make it can be transmitted through the means of optical fibers. And about 90 or TV channels can also be transmitted by news of optical fibers. Now, let's look at the expected answer for the question here. Let's see the 3 uses of optical fibers in manufacturing industries. For the sake of simplicity, I will give you 5 uses, and you can take any 3 of them. So it's used for precise laser cutting and welding operations, for sensors to monitor temperature and screening equipment, for high-speed data transmission between automated machinery. Optical fiber can be used to measure AC or DC voltage. Optical fibers are used as hydrophones. Hydrophones, these are instruments that are used on water. Hydrophones are water microphones, usually used on water to detect sounds and on water. So that's what hydrophones are used for. Now, the last questions I saw to explain the basic principle of operation of a fiber optic sensors. Now, an optical fibers sensors operate based on the principle of total internal reflections. Total internal reflection usually occurs when light ray is moving from a denser medium to what? To the light denser mediums. It produces an angle that is greater than critical angles. At that particular point, total internal reflections occur. Light transmitted through the code of the fibers, and any changes in temperature, pressure, or screen alter the demand or properties of light. This change is detected and analyzed to measure physical quantities. So these were the expected answers for question number 5. Let's move to our next question, question number 6. In a tabular form, state 3 differences between crystalline solid and amorphous solid. So let's see. I'll give you 4 differences. You can take any what? You can take any or 3 of them. 1, crystalline solid. In a crystalline solid, atoms or molecules are arranged in a regular repeating pattern. In fact, crystalline means something that has a regular shapes or something that have what definite shape. What amorphous mean irregular or what indefinite shapes. So for crystalline solid, it has a well-defined edges and what and surfaces. What amorphous has or curved surfaces. And crystalline solid, it melts at a particular temperature. What amorphous, it melts over a wide or range of temperatures. So I give you 4. You can take any one, any 3 of them. Let's move to our last question. The last question says we should provide 3 evidence that support the molecular nature of light. I will give you 6 evidence, and you can take any one, any 3. What the brand motion, diffusion of gas, gas pressure, kinetic theory or gas law, and Easton model, and Americans all drop experiments. So these were the expected answers for WASSCE 2025 phases 2. Thank you. I'll see you in my next video. You can check the next video for the remaining 5 questions. Thank you.